Hi guys, welcome to PCMINR.com and you're watching this video on non-uniform motion by Sonal Gupta. So far we learned about speed and velocity in our previous video, and now we're going to learn about uniform and non-uniform motion. So how do you come to know that a motion is uniform? So when an object, say it covers equal distances in equal intervals of time, we say it's a uniform motion. For example, you can just check out for this data. So here I have x and time t. So maybe x you can take in meters and time t in seconds. Suppose the distance covered is 2 meters, 2 meters, 2 meters, 2 meters and 2 meters in the first second, then 4, then 7, then 10, then 13th second. So in every interval of 3 seconds, right? So the interval is 3 seconds for every going from 1 to 4 if you're noting down the time. So you noted at 1 second, then 4 second, then 7 second. So the interval is 3 seconds. Or okay, rather we can ignore this one and we can just hook on to the intervals. So I'm just writing down the intervals. But on the other hand, if an object, it covers unequal distances in equal intervals of time, then the motion would be non-uniform. Like for example, now we say x and t. Now I'm keeping the same intervals, 3 seconds, 3 seconds and 3 seconds, and the distance you're covering might be 2 meters, then you covered 3 meters, maybe then you covered 5 meters, then you covered 4 meters, and then again you covered 2 meters. So in every 3 seconds, every interval, the distance that you're covering is not same, as you can check it out. So this type of motion where the distances covered are unequal, as you can see, in equal intervals of time, then it is said to be a non-uniform motion. So what can you say about the motion that you have on a crowded road? I'm sure you cannot drive at a constant speed or a constant velocity on a crowded road. So that means on a crowded road, you would have a non-uniform motion, right? And when you have a change in the velocity happening because you're not covering equal distances in equal intervals of time on a crowded road, so your velocity, your speed is not constant. And what measures that change in the velocity is called the acceleration. So acceleration is a new quantity now we introduce here because now we are talking about the change in velocity and how do we measure that. So acceleration is a measure of the change in the velocity of an object per unit time. So mathematically you would say acceleration is the change, delta is generally used for change. So delta V upon delta t, the time interval. So that's change in velocity upon change in time, or whatever is the time interval. And so what should be the unit for acceleration? Since velocity, whether it's change, it will be in meter per second upon another second. So you get meter per second square as the unit for acceleration. And if you consider an object, say it was initially traveling with the velocity u, and in a time interval t, it reaches here and it acquires a velocity v, then how would you give the acceleration? The formula would be a is equal to v minus u, that is final velocity minus initial velocity upon time. So this is a very, very important formula. A is equal to v minus u by t, which we are going to use further to derive more equations. Another thing you need to note down here, see, you're not always increasing the velocity. When you come across a traffic jam, you also decrease the velocity. It increases, decreases again and again. So based on that, we say the acceleration is positive if it is in the direction of velocity. That is, your final velocity will be greater than the initial velocity. Like a train starts from a platform and on the middle of the path of the journey, it's almost at a full speed. So the final velocity there is greater than the initial velocity. So the body is speeding up. That is positive acceleration. But the acceleration is negative if it is opposite to the direction of velocity. That is, if your final velocity is less than the initial velocity, right? If it is less, then in that case the body retards, and hence the negative acceleration is known as retardation. So like when you come across a traffic jam, you actually you're facing retardation in the motion. Another interesting thing is, because now the velocity is changing, and since the change in velocity causes acceleration, therefore whether the body, we say the uniformity or non-uniformity of acceleration, it depends on how the velocity changes. So just like we had uniform motion and non-uniform motion, now we have uniformly accelerated and non-uniformly accelerated motion. So if an object, it is traveling in a straight line and its velocity increases or decreases by equal amounts in equal intervals of time, then the acceleration of the object is uniform. For example, you have a freely falling body. So this ball, it falls here down and the gravity is pulling it down. The acceleration here is actually g, the acceleration due to gravity, and this is causing a constant increase in the velocity of the body. So when this ball, it falls down, it's the maximum velocity, and in every interval it is increasing by equal amounts. So this velocity, this acceleration, the one due to gravity, is uniformly acceleration, and the motion of a freely falling body is therefore an example of uniformly accelerated motion. And on the other hand, now an object can travel with non-uniform acceleration if its velocity changes at a uniform rate, non-uniform rate. So here we see there's a car, it is going along a road. So when it is going along a road, it might face a lot of traffic. So sometimes its speed will increase, sometimes it will decrease, and every time the increase or decrease of velocity is going to be by unequal amounts in the equal intervals of time. And therefore, the car will be said to be moving with non-uniform acceleration or a variable acceleration. And generally, your motion on the road is not only non-uniform, your motion of a car, we can say, or any vehicle on the road is actually a non-uniform acceleration. So out of non-uniform motion, you further have two further types, uniformly accelerated or non-uniformly accelerated. But generally your motion can't be uniformly accelerated. Like I told you about the train, it will once increase its speed, so it's a uniform acceleration. But when we talk of non-uniform acceleration, the motion on the road is generally, you increase sometimes by a high amount, sometimes by some other amount, you will slow down. So that is a non-uniform accelerated motion. So in the end, I would like to conclude with that you should know that motion is of two types, uniform motion and non-uniform motion. Uniform motion means the velocity is constant, but non-uniform motion means the velocity is not constant. So how the velocity changes, based on that you have non-uniform motion as uniformly accelerated if the velocity increases or decreases by equal amounts, and non-uniformly accelerated if the velocity changes by unequal amounts in equal intervals of time. If you find this video helpful, please subscribe, like and share, and follow us on Instagram and Facebook at PCMINR.com. Thank you.